Welcome back to part 3 of Centroids complex shapes. In this one we'll talk about the subtractive method. Excuse me, I'm going to go through this a little bit quicker. 1, because I'm tired and it's time to go to bed, and 2, because it's just an alternative method. Sometimes this will be easier. Actually, you'll see with a couple of shapes that we do, it's often easier, but it's just something to be aware of. Once you get the hang of it, you'll see it's not that different. So we have the same shape here. Notice we have this giant square with just a little bit of a void here. And what we're going to try and do is we're going to take the centroid of this whole square, which is right here, at 3, 3, because we see half a base, half a height, 3, 3. And then we're going to subtract this centroid stuff, which is shape 2, the triangle. We're going to take this centroid, which is right here, to be over 1 and down 1 from this corner. We're going to subtract that from it to get our final centroid. So, calculating, again, we follow the same steps here. So, calculating the area of each shape. Now our giant square has an area of 36 square inches because it's 6 inches tall, and we're saying 6 inches over. We're pretending like this is part of the square, and then we're going to subtract it out. So, the entire square would be 6 by 6, which is 36 square inches. The area of this little triangle, the voided triangle here, is negative 4.5 inches squared because we're removing it, so we have a negative area there, which you'll see how that works out here in just a minute. So, just like I mentioned before, we find our centroid location. This one's at 3, 3. And this one is at over 1 and down 1. So take a second, pause the video, see if you can figure out what you think the XY coordinate pair for this is going to be. Hopefully you came up with 5, 5, because it's all the way over, but back 1, which is 5, all the way up, back 1, which is 5, because it's 1, 1 from this 0 spot up here. We'll measure everything from our XY 0, so this centroid has an XY coordinate pair of 5, 5. This one has an XY of 3, 3. And so we go back to these same charts that we used before, where we have the area times the X coordinate, 108 cubic inches, and the area times the X coordinate of the triangle. Notice this is a negative area, which is going to give us a negative value here, which is good because we're going to actually end up, when we take the sum of these two, we're going to subtract them because we're subtracting this corner out of this block. We do the same thing in the Y dimension, 36 times our Y coordinate, or our Y centroid, and negative 4.5 times our Y centroid for this triangle. Again, negative value because we're going to subtract it. We go back and we take the sum of all the areas times the centroid, so we have 108 minus or plus a negative 22.5, negative because we're getting rid of it, and same thing in the Y. And you notice, you can see here we're at 85.5 again, whether we add 3 shapes or whether we take the big shape and subtract out the missing corner. From here on out, it's basically the same. We're going to take our areas, almost the same. We're going to take our area and add them together, except remember, the giant area is 36 square inches. We got to subtract out the area of that triangle that's no longer there, which gives us a sum of areas, which is 31.5, which is like we got when we did the additive method. We plug those into our equation. Sum of area times X centroids divided by the sum of the area is 2.71 inches. And the same thing for the Y, sum of the areas times the Y centroids divided by the sum of the area, 2.71. Again, line symmetry through this shape right through there. So, now hopefully you get a little bit of an understanding of what these equations mean. Hopefully they don't look so frightening. Hopefully you're feeling strong and powerful and ready to save the day with centroids. That's all for tonight, folks. Have a good evening, and we'll see you later.